I think really one of the most exciting things about Postgres is how boring, is kind of the boring things like reliability uh, and predictability, documentation, compatibility, standards adherence, things like that. So earlier in my career, what I noticed was a lot of senior engineers that I looked up to or were mentors to me, they were choosing Postgres. And this is even 10 plus years ago. And, I didn't really think about it a lot. I was like, well, it's a relational database. Like, there's also other ones. But what I've found too, and I've heard others recommend this in my career, is kind of like, if you have engineers that you look up to, that you respect their kind of decision making and choices and that sort of thing, kind of consider doing what they do, right? They might.
Hey there, everyone. Welcome to yet another Teach Kevin Your Thing session. You'd notice I normally have the usual one screen of me, but right now we have the guest immediately because I'm trying something new. So I'm having Andrew Atkinson on the show today. We are going to be talking about Performance PostgreSQL for Rails. How you doing, Andrew?
Doing well. Thanks for having me. Excited to be here.
Yeah, for sure. Me too. Like I was telling you before the show, this will be the very first non-JavaScript web development session, and I'm really more excited. I think I should be more excited than you because I've always wanted to like learn more from other ecosystem, and I'm really glad we are doing it in the show. So before we get into all the geekiness, can you just introduce yourself? Tell us who Andrew Atkinson is, what you've been doing, what you currently do, and a fun fact about you.
Okay. Yes, my name is Andrew Atkinson. I also go by Andy, and I've been a software engineer for about 15 years, and about 10 of that's been Ruby on Rails and Postgres with each other. Um, but I've been doing Ruby has been kind of my primary programming language for most of that time. I've also done some mobile development in the past, and my career has kind of gone from full stack web development more towards back end, and then even infrastructure and database administration lately.
Mm.
And yeah, I'm based in Minneapolis, Minnesota, in the United States, and a dad and have a couple of young kids, so that keeps me busy outside of programming work. And recently, I have it's about to be published, but I've been writing a book for the first time, which we
Yeah.
could talk about. That's been a really fun project. Fun fact about me: I'm a big NBA basketball fan, and um, I've been a longtime fan since the 1990s of the Minnesota Timberwolves, which is where my home state is. And the team is finally, it's been decades of being a really bad team, and finally this year we're looking really good. So been enjoying watching that.
Awesome. Nice. Thank you for the fun fact. And also, I'm a big fan of Rails and Ruby, especially what the ecosystem have brought to web development. Shout out to DHH for, did you see the Rails documentary?
I did start watching part of it, and I was going to mention it if you hadn't seen it. I
Yeah.
think for people that are completely unfamiliar with Ruby on Rails, it would be a fun way to
Mm-hmm.
kind of get a flavor of the history behind it. It's been this year also, besides the documentary, was a new conference called Rails World in
Yeah.
Amsterdam, and there was a lot of I wasn't able to go, but there was a lot of energy and kind of like it's a 20-year-old web framework,
Mm-hmm.
but kind of a lot of a like a renaissance or kind of a new zeal or enthusiasm for it.
Yeah. And he also broke the internet with no build as usual with the classic DHH style. I think I saw the keynote like twice or thrice because I really love the I I I've always loved DHH for what it's doing in web dev, his ideology. They're very strong, so it was really fun to watch. And so yeah, so you a quick question: what is it about Rails and Ruby that got you, to be doing it for this long?
Yeah, it's a good question because it's been a long time, and there's certainly lots of programming languages and other technologies. I think I actually was thinking about this recently, but here in Minnesota, I've lived in other states as well, and but have always lived in the United States. But here in Minnesota, back in the 2000s, there was a local Ruby users group that was pretty formative for me. There was a lot of senior programmers in there that were friendly, and it was a good place to go. And it was one of the first places I ever did a presentation. And um, at the time, I learned Ruby in the 2000s, coming from working at a company where we used enterprise Java, and it was kind of my first job out of university, and I was writing Java code, and it was this huge, enterprise legacy app. And like a lot of people, I got hooked on. It was in an era of my life where I had a lot of time and was, really learning a lot of new technologies. And um, this combination, I guess, of Ruby on Rails being out in the mid to late 2000s, um, and kind of trying it out, having this supportive local community, buying books, trying to learn new technologies and be kind of individually productive, building web applications like full stack, set up the database and set up a front end, set up an API layer. Um, it was kind of this combination of things, I guess, where I could be, I liked the Ruby programming language because it was very, and still is, it's considered a pretty accessible language, very readable, more like English than a lot of other languages. Um, which makes it easier, I think, to learn initially, but also to maintain big apps and kind of learn the domain. And then that combination of productivity, feeling like it was kind of on something really new at the time compared with Java and that sort of thing.
Yeah.
And then having that supportive local community I mentioned, and resources to learn from. And then I guess over time, I think part of why I stuck with it is like, you build a network, right, as a programmer. And
Yeah.
I started to go to events. I had the opportunity to go to, to kind of go to RubyConf and RailsConf and other events that were outside of my home city, and met people and worked for companies. And yeah, now looking back on it, I guess like it's nice to know that it's, part of it too is, of course, you still need to be able to work within, you need to find jobs and that kind of thing. So it's nice to see that it's still a popular choice among a lot of both big applications that are in production that need, might be facing more like scaling challenges or growth challenges, but also it's still selected by new companies that are choosing it to build their core applications in for a lot of these benefits that we've discussed.
Mm. Yeah, that's nice. Really, I like that you mentioned because it does look like English. I think that was one of the reasons that made DHH also loved Ruby enough to build like a framework on top of it. And it just lowers the barrier to entry. I'm sort of like very big on C-like languages, so that's why JavaScript is my thing. But I do get the appeal for things like Python and Ruby that just read like English. So that's amazing. So you were speaking about scaling, and I think we should just dive into the topic, right? Which
Okay,
is
sure, yeah.
which is Postgres, right? So my first question is, why did you choose Postgres between, MySQL? I think MySQL is more popular before Postgres, and there's also NoSQL. So in this day and age of, there's always a serverless this or that, or MongoDB or any other serverless or NoSQL database. Why do you go with Postgres for REST applications?
Yeah, it's a reasonable question. If you were a brand new developer that was trying to invest your skills, you might think, well, um, if you wanted to choose, like you said, first you have to kind of, or invest your time, I guess, in learning new skills is what I meant. First you have to, if you're building an application, you need to store data, and you have to kind of choose between a non-relational or a relational database. And the that's a big upfront choice to make. And some organizations over time might actually run multiple databases. That can be pretty common. Databases might um, have a special purpose, like a search database or a key value store. We could talk about that.
Yeah.
And but yeah, to answer your question, it's an interesting question because I think what happens is a lot of times you join a new company and it's not like a decision you'd make. It's already been made. If there's an existing application, most jobs are not
Yeah.
greenfield, or brand new jobs. You're coming into a company that is adding engineers to the team to help meet their growth goals and that kind of thing.
Yeah.
So you might just sort of get, you'd work with what's available or what's been selected already. Um, but if you're in a position to choose, I do think it's worth considering. I don't really spend a lot of time researching, like pitting Postgres against other relational databases, but I do know some of the things that we have vector search or whatever, which there is also in Postgres, and I can talk about. But I think really one of the most exciting things about Postgres is how boring, is kind of the boring things like reliability,
Mm-hmm.
uh, and predictability, documentation, compatibility, standards adherence, things like
Mm-hmm.
that. So earlier in my career, what I noticed was a lot of senior engineers that I looked up to or were mentors to me, they were choosing Postgres. And this is even 10 plus years ago. And, I didn't really think about it a lot. I was like, well, it's a relational database. Like, there's also other ones. But what I've found too, and I've heard others recommend this in my career, is kind of like, if you have engineers that you look up to, that you respect their kind of decision making and choices and that sort of thing, um, you know, kind of consider doing what they do, right? They might, and ask questions like you're doing, which is, why. Um, but yeah, I sort of picked up Postgres on my own, and 10 years ago plus now, there was a really popular platform as a service called Heroku that you might be familiar with. It's still
Yeah.
running, still available. That sort of really, for the Ruby on Rails community, it really hard to getting a Rails app online and then it was powered by Postgres. And for a lot of people, that was really how they used Postgres first, I would say, in the Ruby on Rails world. And once you learn a tool and you become, proficient with it, it's even as an individual developer, it's nice to like stick with it to kind of deepen your skills and that sort of thing. So to wrap up my answer, I guess, um, I think there's a lot of reasons if you look today, and actually Postgres keeps annually, year after year, is getting more and more popular to where it's projected to become the most popular relational database chosen by developers. I can share with you some surveys about
Mm-hmm.
that show that. Um, so I think there is actually a really bright future for Postgres also in terms of popularity and adoption, which also means employment and opportunities to really use it. But even if you're just using it for your side projects, it's also a really efficient and small kind of database that can be used on even small instances, and it can allow you to work on it both for hobby projects or even at huge scale companies.
Mm. That's quite interesting. So I like that you mentioned that Postgres is boring because I think I've been using it since 2020 for my project. I don't, there wasn't like a serious reason really. I think I've experimented with MongoDB, MySQL. Then I don't know why, but I just sort of liked Postgres and I've just been using it because, like I said, it's boring. It's not anything flashy. And I use Sales, which is like the Rails equivalent for Node. So once I just set it up with the adapter, I don't really think about Postgres. I just use the ORM to interact. So it's just a way, but I
Yeah,
just prefer Postgres for some reason. Right?
that's nice. Yeah, that makes sense. And that's the idea, right? Is that, a lot of what my book is about, which we'll get into a bit,
Yeah, for sure.
is like when you get to a certain, Postgres works great for a really long time, right? Like,
Hmm.
in fact, I don't really, my book is not really targeted at brand new users, or although I'd love anyone that wants to buy it and read it and has
Yeah.
feedback, that's great. But like, um, Postgres is a great choice for getting started. And the reality is, like, you're not going to really run into many operational problems.
Yeah.
You know, you tend to see challenges like you would with any relational database. Anytime you're running really high volume SQL queries on really huge databases, whether it's Postgres or anything else, you're not going to see those things until it's kind of huge.
Hmm.
Um, one more really quick point too about Postgres that I like and that folks talk about in the community a lot is there isn't one entity that owns it or drives it. Even
Yeah.
if you look at the core team that contributes to it, they work at several different companies and consultancies. And increasingly, even the major cloud providers are hiring developers full time to work on Postgres. So Microsoft, AWS, and others. And then there's a lot of other smaller companies that have folks that are working on it full time as well. So I like that too. It doesn't feel like tomorrow, kind of on the whim of some company, there's going to be a big change, right? It's like that's
Yeah.
not going to happen with Postgres. It
Yeah.
has a good governance structure, so that's nice.
Yeah, definitely. And I feel like for me, I probably like I don't even worry about the core team or anything. It's just that boring and stable. I don't really care. But I'm going to ask this question, and I think you might have touched on it in your book, right? For most apps, so for most app specific code, you're probably going to use an ORM. You're not going to write SQL. So at what point, if we're going to do like a spectrum, right? When
Mm-hmm.
do you go one level down to SQL? If you're using something like Rails, of course, I know you have active record, right? So do you
Mm-hmm.
ever have to drop down? And why? Is it performance reason or what? Because of course this is a performance session.
Yeah. Well, do you want to get into? We could talk. I could talk and show some code at the same time. It might be
Yeah,
easier too.
yes, please.
Okay.
Let's see some
Yeah. Let's
SQL.
do it.
Yeah.
Okay. So I moved. Right. Okay. I moved my video down because it's hard. I want to look at the camera to look at you. But anyway, so you
Yeah,
should be
that's
seeing
fine.
my editor now.
Yeah,
Is
yeah.
that right?
Yes, I
Okay.
can.
Cool. So I have tmux here, and I have a couple of different sessions going just to
Mhm.
orient what you're looking at.
Yeah.
That the book has this Rails application that's on GitHub. It's open source. It's called Rideshare, and it's kind of
Okay.
like you're probably familiar with Uber or Lyft or other kind of like on-demand ride-sharing services,
Yeah.
and it's kind of like a mini version of that with a few models. And there's a entity relationship diagram in the project
Oh,
that you can take
nice.
a look at, which has these models. So
Mm-hmm.
actually, let's just look at one to discuss your question about
Yeah.
active record, the ORM versus SQL.
Mm-hmm.
So this let's look at maybe the trip or maybe the
Yeah.
trip request. So the idea of rideshare is, or like if you've used any ride sharing service, you want to ride between where you are to some destination. And so you make a trip request. And then that trip request is dispatched to an available driver who will come and pick you up, right? And then at that
Yeah.
point, the way the application models it is then there would be a trip. So a trip would be between two locations and it would have a driver and a rider, that sort of thing.
Yeah. Can you zoom it a
Um,
little bit? It's
yep. Yeah. Let me do that. Okay.
we can see. Oh yes. Now we
Yes.
can.
Okay.
Perfect.
Yep. And if someone's looking at this later, I will just pull this up here. Actually, I have it open. They
Mm-hmm.
can go to.
Yeah. Uh,
We can discuss these links, and I can give them to you as well.
yeah,
They can
sure.
go to this rideshare app, and then they'll see in the directory here. There's this ERD PDF that they can check
Oh,
out.
perfect.
Um, so we're going to look at the trip uh, um, model,
Mm-hmm.
and in Ruby on Rails, actually, I'll go to a full screen editor window. Okay, so I'm just in the rideshare directory here, and I'll just open it in an editor. And then I'll open this model. So I'm in, on the left-hand side here is the file tree
Mm-hmm.
thing. So Rails
Yeah.
apps, I'm in rideshare app models, and then I'm in the trip model.
Mm-hmm.
And the active record ORM, as you mentioned, it maps this trip model to a trips table. So let's take a look at that. I will go to the rideshare. I'm just going to check that I have a. Okay, so I'm going to connect to my local instance and
Yeah.
then the rideshare development database, which
Mm-hmm.
is the database for this running instance. And if in Postgres, I'm using PSQL for the command line client, and if I do /det, I'll do it's the meta command for describe table. we can see these tables. And again, these are just the tables that we saw earlier in this document in the
Yes.
ERD. And a real application would have hundreds, or a bigger application. This just has these like 10 or so. So we can see one of the tables is trips, and we can see it's in the Rideshare schema, which is a schema in Postgres for this application's tables and database objects. We can do describe trips \d trips, and then we can see the fields on the trips table, any indexes it has, constraints, and things like that.
Mm-hmm.
And then we can select rows. So I'll just pick one row, and we can see the row or the column data for a trip row. This is just one of the rows. We can see it has a, actually, I think I started talking about trip requests and I switched to trips now.
Yeah.
So trips have a foreign key to trip requests.
Mm-hmm.
And where are we going with this? Okay, where we're going with this is,
Yeah.
I know you're like watchers are familiar with what ORMs are, so I'll just wrap it up here. But kind of a intro to this trip record, this trip model that we see.
Yeah.
Whenever we save instances of it in the application, then they get inserted, of course, as rows into this table. And then on the other hand, when we query instance, so like let's find a query trips controller. Where's a good one? I'm going to just pop around here a bit. When we call methods that involve accessing data, then they're going to, using Active Record, they're going to query the tables that are backing those models.
Mm-hmm.
And your original question, then, getting around to the answer finally, is when would you drop down? The places I would drop down would be where I want to do some query performance optimization, and I kind of want to see what the SQL query looks like that's generated by Active Record from the perspective of the query execution planner in Postgres.
Mm-hmm.
And usually I wouldn't really do that until, usually you can just kind of write standard Active Record queries or ORM, code that generates queries. But what I recommend to folks is like they try to get familiar with their production observability and visibility tools, which could be an APM or something else.
Yeah.
And you want to kind of start from there and say, how are my queries performing in production on the instances where they're running? And then at that point, go back and trace back into the application and start to dive into, well, okay, what are the components of this SQL query? And then how does the query planner interpret those? And what are the things I can do? Like we can talk about indexes and query changes and schema changes that can influence the execution speed. So what are your thoughts on that?
Yeah. So my thoughts are mostly you're good, like, when you're using a good ORM like Active Record, you probably will need to drop down. But for more monitoring and trying to like see how your queries are performing, you might need to do that for SQL, right?
That's right. Yeah. So in fact, probably what I should have done to dive into that was just load up one of the great things about Ruby is you have this interactive Ruby interpreter that's available to you. And this is outside of Rails as well, but it's called IRB, Interactive Ruby. And I've just launched it here in the bottom. Are you able to see that?
Yes, I can see that.
Okay. Okay, great. And then Ruby on Rails extends that with and loads all of the Rails code, and that's called the Rails console, which you can launch by running Rails console.
Mm-hmm.
And I just want to do that with bin Rails so it runs the right one. I'm going to just actually clear that out so it's easier to read. Mm-hmm. So what this does is it loads IRB, and then it actually also loads all of these Active Record models as well. So we can do SQL queries, but through that ORM. So we can do like trip.first. This is Active Record code, but I have this set up so that, and I think it does by default, but it actually logs the SQL. So we can see here, this is 100% identical to what I did before, where actually I'm gonna if I take that SQL query, right, and I just paste it in here, so it's a little bit hard to read because it's enumerating all of the columns and it's putting
Yeah.
all of these in double quotes. But if I run it, it's exactly the same, right? And
Yeah.
what's happening is the ORM queries that table, gets the row, and then creates this active record instance. But like if I'm just going to make this window the full window,
Mm-hmm.
it's kind of hard to, like, if you're in a performance optimization situation,
Yeah.
it's for me it's more difficult to iterate in this context, like if I'm in active record. So what I typically do is you can do like active record gives you this option where you write to underscore SQL on a relation. And then what that does, which you might guess, is it dumps the SQL query.
Mm.
And I can say print, and then it's nicely formatted. So what I can do then is I can come over here and then run that. I'm going to do a limit on here, but I can run that in the Postgres PSQL client,
Yeah.
and then I can start to do my analysis that I might do. Like
Mm.
I'm going to do this same query, but I'll do explain on the front of it. Actually, I'll do limit 1, and we can then start to look at the estimated query execution plan, and then we can start to add in more capabilities that show us more information, like the timing. This query isn't very exciting, so there isn't much in the plan.
Yeah.
But yeah, that's where I would go. Is I would work on the query optimization portion of performance analysis with SQL, and I would make some changes to the query. Like, let's say I decided to um, remove this field. Like, I don't need this field. Uh, so I run my SQL query, and in this case, it doesn't make a difference. But let's say it made a difference. What I
Yeah.
would then need to do is go back and translate that into my active record code. So I might change this from all to like select, which is
Mm-hmm.
again an active record method,
Yeah.
and I would say just select one column from this, and so we get a active record instance here, a trip, but the only value that's populated, like
Mm.
let me show you again here, trips. We know that there's a driver ID, for example, but
Yeah.
up here in the ORM, since I said I only want the ID back in the response, it's only creating objects that have the ID column value placed into the instance. So if I tried to access something else, like let's say I'll assign this to the first, and I'll assign it to the trip. If I tried to access like the driver ID on this, we'll see an error because the object wasn't initialized with that column value.
Mm.
And the purpose of showing that, I guess, here was that, if you're doing optimization work, then you need to sort of reverse translate, if you're doing it in SQL,
Mhm.
back into active record. So it might be like changing the columns, changing the tables that are queried, adding a limit, that sort of thing.
Mm. Yeah, that's really interesting. So I guess totally you don't have to get rid of SQL totally if you're using an ORM. So your SQL skills or SQL skills still gonna come into play. So let's talk about some real world examples or scenarios, maybe from your book.
Sure.
Like at what point do you find it important or necessary to start fine tuning the performance of Postgres? Because to me, as a not a power user of Postgres, it's doing well. But I guess you definitely know better because you're writing a book on it or you've written a book on it. So at what point, with like examples or in apps you've seen, that's like, okay, we need a book to teach people like how to really make their Postgres highly performant for REST application. Yeah.
Yeah. Um, yeah. So, like, kind of like what we said early on, I don't think most folks will have any trouble, whether it's Postgres or a different relational database, until they start to get into hundreds or thousands of transactions per second, and they start to get to databases that are sized into the, you know,
Yeah.
gigabytes, or even of course like into the terabytes or next kind of size uh, tier. And
Mm-hmm.
often it's because the amount of concurrent activity that's happening, because databases are designed for a lot of concurrent use, right? You have a web
Yeah.
application with, like, if it's a Ruby on Rails application or something else on the internet, and especially if it's a consumer-oriented app with lots of people all over the world accessing it, there's a lot of concurrent activity. So that could be writes and reads that are happening at the same time. And in the earlier days of any application, if there's not a lot of concurrent activity, your relational database is not even going to break a sweat.
Mm.
Where you start to see challenges are when you have many hundreds or even thousands of concurrent sessions, and
Mm.
these sessions could be even concurrency that's within a really, really narrow window of time that is, to us as humans, is like really small, like 100 milliseconds, but like 1,000 concurrent sessions within a 100 millisecond span or something like that.
Mm.
Databases are designed to work in that scenario, simultaneously handling needs to access data, to read data, and to write new data, and to keep everyone's view of the data, not stomp on changes from other concurrent users, and make sure that concurrent users are reading data that's only been properly and fully inserted, and that kind of thing. So yeah, concurrent sessions, and then also just um, database size and table size also is another factor where, like, if you've got a modern instance, you're on a cloud hosted Postgres, and you've got a database that's like 1 gigabyte or smaller, I mean, you're not going to really be moving a lot of data back and forth or around between the client application and the database server. So that's another place where, over time, if your application is successful and your business is successful and it grows and grows, and you start to get into the 10 gigabytes, 50, 100, 1 terabyte, 5 terabytes, um, all of those queries, if you write queries that are not kind of tight, or kind of narrow, like they have well scoped columns,
Yeah.
limited numbers of tables. If you think about it, and you think about it like in a physical sense, um, if you went to like a huge warehouse and you're like, well, here's where all of our stuff is, and like, versus like a little tiny little store with like one room in it or something.
Mm.
If you're a huge warehouse and you're like, here's all of our stuff, I need to find this one thing, right? Like, I need to find this one, like, imagine like a Amazon distribution center or something. I've never been in one, but
Yeah.
like, I'm ordering toothpaste, like, it's in this warehouse somewhere and I need to go and find it. And imagine how long that would take versus, like, I need to find toothpaste in this room, like one room, small store, mom and pop shop or whatever.
Mm. Yeah.
Um, and that's, so again, with databases, they are designed to work, in this kind of metaphor of like a huge warehouse. They're designed to work that way too, but it really depends on
Mm.
the operator or the user of the database to take advantage of what's available, which would be like well placed indexes, well written queries, things like table partitioning, we can discuss if we have time, and stuff like that.
Yeah. Yeah, definitely.
So,
Go ahead.
I was just going to say, what I was showing here is Postgres has all of these. I'm just going to show this one: Postgres bgstat activity.
Okay.
There's, if you've never seen the kind of visibility, again, these aren't like very pretty or visual.
Mm.
But Postgres itself tracks loads and loads of things internally, and it exposes this information through what it calls system catalogs. If you haven't seen these before,
Yeah.
and like, one of them is pgstat activity, and that is what I was just showing here. So it's kind of like it's a table that you didn't create with your application. It's not a Ruby on Rails table, and it's actually not a table, it's a view, but you can query it like as if it was a table using SQL. And I'm querying the pgstat activity view here, and what this is showing is it's showing 8 rows, and there's 1 row per like activity that it's exposing to me to see. And they
Mm.
have different types. Like, some are going to be um, client connections. So with my Rails console where I connected to Postgres, that's what we're seeing here. We're
Yeah.
seeing the Rails process. Some of these are the PSQL sessions, um, and I'm out of space here on my screen. But the other ones would be backend processes or things that are happening in the background by Postgres. It's doing like maintenance operations and other things behind the scenes.
Yeah.
Um, so yeah, you were asking about like how do I and the book there's different places where it discusses kind of the observability or the visibility into Postgres. But an important part about being an operator, in my opinion, is to learn the places where you can go and see what's happening, right? Like what are the queries that are running, which queries are being blocked by locking, what are my biggest tables, what do my indexes look like on tables, all those sorts of things.
Yeah, for sure. So there's this quote which is you can't improve what you don't measure, and
Yep.
I really haven't done the PG style activity ever. I don't think I've ever seen it. So definitely gonna go try out that one because um uh, uh, just like you mentioned, at a particular level, you have to care about what queries are happening, especially because of this concurrency. Because of course, on the web, you could have like maybe 10,000 users connected or and making the same queries, and you need to know what is the bottleneck because we've always said that the database could be the bottleneck to how fast or slow your application is. So with all this instrumentation tooling or stats, I think that's really good. I'm definitely going to go try it. So you mentioned something, and just quickly, right? Like let's go through like things like the role of indexes, sharding, and partitioning in improving the performance of your database because you did mention index and you were glossing on partitioning a little bit, but let's just touch on those. Like I don't think I've ever worried about indexes before. I just set the index like the primary ID and I don't really pay any more attention to it. But I've always seen at a particular level you need to care about what is being indexed, and of course you don't want to index everything. So let's
Right.
start from there, from index, sharding, then partitioning. Like, what role do they play for the performance of Postgres?
Okay. Yeah. So indexing is a huge topic where there's whole books written about it.
Mm.
So just to give you like a little bit of a flavor, because I know we want to try to cover a bunch of topics
Yeah.
and I tend to talk way too much. So I'm gonna try to go quickly. So
Okay.
I think a really simple example is, if you look at your tables, which again, I'm using a command line client to do this, which I
Mm-hmm.
have readers learn to use in the book. But there's also much easier to use like GUI clients as well. And if
Yeah.
you only use a database occasionally, like go for it, use a GUI client. If you work with a database a lot, I do recommend learning PSQL or equivalent. But so let's look at this trips table, and I'm listing out the columns, and then let's dive into this driver ID column again. Uh, and again, this you'll need to like translate all of this to whatever database you're working with. But
Yeah.
the idea is that I'm using this Rideshare app to sort of be an example, and you can try to translate what you're seeing here into your specific scenarios. So, like, imagine that you had a query in Active Record. I'm not going to run this because it wouldn't be valid, but
Yeah.
that where I did something like this: driver ID equals 1, and so this is going to generate a query that is going to be. And if you use your ORM and you're familiar with SQL, you can kind of translate it in your head. But it's going to be select star from trips where driver ID equals 1,
Yeah.
and
Limits one.
um, yep, that's right. Yeah, and yeah, because I added that on there.
Mm-hmm.
So then I can go and why do we care about that for indexing? Well, the way that the query planner treats that is that uh, if you're anything in your where clause of your query is what it would consider a filtering operation.
Mm-hmm.
And filtering operations are great places where you want to have an index that covers that column that's being filtered on. Because what the index is really doing is it's taking all of that column data. So now let's list out the this. So it with and actually I just saw this trick yesterday. We can do
Mm-hmm.
di So this is described index, and then you can give it a pattern. And this just narrows down what we were looking at with all the columns and indexes and constraints, just to the indexes that match this pattern, just
Nice.
for for easier viewing here. So we have indexes that cover. Although actually, now that I see this, I want to go back to this other view because I like it better. We can see that, imagine I was filtering on the driver ID column in a where clause. What we want to do is go and check and make sure that that column is indexed. And we can see that it is here. So there's this index with this name, and it's a B tree type, and it covers this column. And that's really the main, that would be, I would say, with limited info, that would be the main thing I would like to share about indexing is anytime you filter, so like your where clause, your join conditions, make sure there's an index that covers that field. It could be a single column or it could be multiple columns, which we call in Postgres a multi-column index. Other databases call it a composite index. So yeah, go kind of just an easy thing to do is like whether, regardless of whether you use Ruby on Rails or any other technology, anything that's generating a SQL query, see which columns are filtered on and go and check the indexes on the table.
Okay, so quick question. Is it
Yep.
assumed that like in this case, active record is smartly creating the index, or in your model, you are telling it what indexes to create?
It's always your job to tell
Oh,
Postgres what indexes to create as the programmer.
okay.
Postgres, and I believe I don't know that any other relational databases automatically add indexes. There's a couple of exceptions.
Mm-hmm.
Primary keys, for example, they automatically add an index because they need primary keys, which we see there's one here, trips primary key.
Yeah.
They need to be unique on the column where the primary key is defined, which is the ID column in this case. They need to be unique across the whole table, all the rows. So to do that, they use an index so that the lookup is really efficient, and it's part of the primary key constraint is an index is created. But anything else, most of the time, and that's really where the art and science kind of comes in with indexing, is
Yeah.
most of the time it's the job of the programmer is to say, what are my queries like? And then go and find indexes and create indexes that match, or what some people say support those queries well. And I kind of glossed over this too, but let's really quickly see an example here. How do we then know, right? So I'm telling you, oh, you should have an index on driver ID, but like, how do I know that it's actually used? That's where you use the query execution planner to confirm that. And would you like to see that really quick?
Yeah, for sure.
Okay, so imagine this query then: select star from trips where driver ID equals 1. I don't know if there's actually any rows. Let me see what the so what I'm going to do here is select driver ID from trips, and I'll just do 3 so I can get 1. Okay, because I don't know where the sequence was. Okay, so I'm going to run this query, and there's a bunch of rows, which I guess makes sense. Like this means this driver ID fulfilled all these trips, which we can see in this column. So to confirm this then, and this is going to be different for different databases, but in Postgres, you'd want to look at the query execution plan. And there's a couple things you can, I guess in the interest of time, we're going to do explain in front of the SQL query text to look at the query plan. And then we can explain also takes arguments and whatnot too, but I'll do analyze. We can see a little more. Yeah, it's fine. And this is a whole thing that we don't have time to really dive into, and this is a fairly simple one, but these can get very complicated with pages of information. But there's just really one thing we want to look at here, which is this row. And what this is telling us is for this database, for this data and this distribution of values in this driver ID column, Postgres thought it would be most efficient to perform this query to use this index. And we can see then the index name in the query execution plan. So index trips on driver ID. And we get some information about the number of columns and where the data came from, whether it was in the index or in the table storage area of Postgres and the data in the internals. But the takeaway here is that we want to see that this index that we created was used in the query. if we were to drop that index, which because this is not a production database or anything, I can do that. I'm going to run drop index with that name. And then I were to, actually I don't need to analyze the table. I'm going to run this exact same query again. Now what happens is if you just kind of visually compare this to this, you can see how this is different, right?
Yeah.
Before we saw that the bitmap index scan type was used with that index. Now we're actually not seeing any of that anymore, and which
And
makes sense because Postgres, it can't use it, it's not there. And so now it's doing what it's called a sequential scan, where it's going to read all of the rows of the whole trips table, and then with all of that data loaded, again going back to the warehouse analogy, basically like in that analogy, there's no efficient way. There's no like catalog to say, here's where the toothpaste is, or here's where the toiletries are, which is
yeah.
what an index is, kind of. So instead, what we have to do is say, okay, well, bring all of the junk out of the warehouse, put it all out on the lawn, and we're just going to go through one by one, and we're going to eventually find the toothpaste and be like, hey, I found it. It's like 2 days later or something. and so that obviously is not very efficient. It works, but it's not efficient. And that's like, we don't want that. So let's add the index back. And you can do that in SQL. With Active Record or any other ORM, typically you do that in the ORM, but we'll say like create index. And then I'm going to use the same name for fun, but it actually can be any name. So create index name, and then I'll say on the trips table, which is the one we're working with. And then I'll say, we're working with trips, right? Yeah, trips, and then driver ID. So this within parens here is the column we're covering. So what Postgres is going to do is it's going to go and basically gather up that column value from like the whole warehouse kind of thing. And then it makes a data structure that's just with that information only. And when we run the query again, lo and behold, or unsurprisingly, if you know how this stuff works, it uses the index because again, it's way more efficient, right? Postgres is going to say, well, instead of going through the whole warehouse, I can go right to where I can use this existing thing, this index object that is a data structure that efficiently allows me to find the exact driver ID I need. So why wouldn't I use that? Of course I would use that. So yeah, that's kind of the gist of indexes, which I find to be, as you hopefully can tell, like a lot, very exciting and kind of fun.
Yeah. Yeah. So I think it's really excited because even as you mentioned about the ID, which is like the primary key, and the reason why it's being indexed for like quick access because it has to be unique. That's really interesting. I haven't thought about it that way before. These are the sort of things you just take for granted. Like, well, it's a primary key, so of course it's an index. But why is it an index? It doesn't matter to at that level. So yeah, go ahead. Mhm.
Yeah, there's this. It's a little. I might have explained it in a way that. I mean, I think what the questions you're asking now make sense, and
Mhm.
if you keep going along those lines, you might see these other things too. Like
The
there's
foreign
this
key.
whole topic of constraints. Yeah, we didn't really get into constraints, but
Yeah.
foreign key constraints, for example, they don't, even though it's a database object you add to your table, they don't by default create an index to support them,
Oh,
which I
okay.
found to be surprising when I learned that a while back.
Mm.
And the there's an explanation within the Postgres docs about why that is, because indexes aren't free. So one other takeaway, hopefully listeners take away, is that I just showed how you would add an index to support a query for the driver ID column.
Yeah.
But if there's other columns in here too, right? There's rating. So should I just go and create an index for the rating column? Well, no, not really. I mean, if you're not querying the rating column, then having an index that makes it efficient to query isn't going to really serve a purpose.
Mm.
And it's going to take up some space, which isn't a huge deal, but a bigger deal is that it actually adds a little bit of latency to when you add new rows or you update rows,
Mm.
because they need those inserts and updates need to go and say like, am I touching the rating column? If I am, I need to go over here and update the rating index also,
Mm.
which can add some latency. So indexes have, it's kind of fun to try to design them well because you want them to work really well for your queries, but you don't want to add too many because they also have downsides to being
Mm.
in your database.
Yeah, that makes a lot of sense because of course it can't be free. If not, we're all just gonna every column should be an index because
Right.
yeah, because of those benefits. But the reason why they are that good is because everything should not be an index. So Postgres will sort of prioritize what those indexes are, kind of make it easy because like making everything an index and with writes is just gonna be very, very problematic. It's gonna add a lot of latency. So yeah, that's really
Yep.
insightful. Yeah, go ahead, Andrew.
Yeah, and you can measure that too. So in fact, we do have an index here on the rating column.
Mm-hmm.
And so what you can do is you can do benchmarks like I could insert 1,000 rows as fast as possible or whatever, a million rows, and I can measure that insert rate compared with having the index and not, and I can see what the effect of having it is. And it depends on again on the queries whether they're touching the index or not. But these are kinds of the things that Postgres developers and are always thinking about is kind of handling high concurrency, performance of both accessing the data but also writing data into the database, trying to balance those things. And then when you look at these things like primary key constraints, foreign key constraints, Postgres will choose not to add an index automatically when there's additional latency that it adds, unless it's when it's not necessary. But there will be it's a common scenario where if you do a lot of foreign key lookups, you might want to add an index yourself to make that lookup faster. And that's
Mm.
something that's talked about in the book as well.
Yeah.
So I feel like I used up all of our time for just indexes, but were there other topics to dive into, or are we out of time?
Yeah, we have three more, and if I'm being honest, there's some more, but I'm really gonna leave the viewers to go read the book because it seems like for example, we just spoke about index and foreign keys, and it was all exciting. So I want to touch on. So let's not talk about sharding or partitioning because I think it's gonna that's another. It's gonna be turtles all the way
Yeah.
down. So, but are there any settings either in Ruby, in Rails land or in Postgres land that a Rails developer can just configure it or just set in order to have a little bit of more performance than normal?
Yeah, that's an interesting question.
Yeah.
Whoops. Let's see about. Uh, so I'm thinking of a few that are related to more like
Mm-hmm.
reliability, but let me see about. Um,
Mm.
the it's. I would say that if you use a cloud provided Postgres instance, which most folks would be doing unless you're an infrastructure engineer or a database administrator, in which case, you might be operating Postgres yourself on an instance. They actually do, like AWS does this, for example. They do some parameter tuning to take us like a what we would call a community distribution or a stock or open source distribution of Postgres and kind of customize it a bit. So, for example, there's a load of. Let's see if I can actually show this really quick. I'm going to make a new window. And then in Rideshare, I have this Postgres directory too, which folks can check out if they want, which has a bunch of sample kind of like Postgres config files. There's a big caveat here, though. If you're using a cloud provider, you're not editing these config files directly. Typically, you're using the cloud provider's parameters, that kind of thing. But
Mm-hmm.
what I tried to do in the book is have someone kind of administer their own local Postgres so that they can build these skills and then translate them to their cloud provider, because I can't obviously write about every cloud provider, and there's it's cost money to run those instances and stuff.
Yeah.
So there is a Postgres .conf file that's included with your distribution, and one thing you'll see in kind of a Postgres tuning 101 is shared buffers. And a kind of overly simplified definition of this is like the memory storage area where when data rows that you're working with in your queries, when they're either written to Postgres or queried from Postgres, they're actually placed into this shared memory buffers area. And the out of the box tuning is fairly low. which means it doesn't use all of the memory that's available on the server. And what you can do is you can tune that up, and you can say, give me more of the memory on the server. And you can do that by changing the shared buffer's value. So for example, you might say like, I want to change this to 1 gigabyte. Whoops.
Mm-hmm.
And then you would, if this was your local instance, this is not actually the real conf file, but you would change the conf file for your Postgres instance, restart it, and it would use more memory for its share buffers on your server. So that's maybe one. On the Rails side, and I think every web application framework would have this, but you want to make sure that you're using all the caches that are built in, which Postgres has, or sorry, Ruby on Rails or Active Record has um, a number of different cache layers, whether it's caching query results, it's caching parameterized or parameterless queries. There's also a general cache store that you can use. So
Mm.
some work kind of automatically and some are available for you to use to put cached data into. Using those things can be a huge speed up. And there's a whole chapter on this. This chapter is optimizing Active Record.
Nice.
And in this chapter, like, although this book is focused on database performance, of course you want to try to use any kind of like Rails client application caches available, because what they typically do is they eliminate queries entirely. So if
Mm.
you can eliminate a query, that's of course always going to be faster than the fastest version of that query is
Mm.
not running it at all, right? Like if you can run the query, keep a cached result that then is served to new web application requests, and then periodically refresh it, for example, that will be the fastest setup on the application side.
Mm. Yeah. Whew, there just seem to be more and more. There, I did have caching as one of the questions, but we're not gonna go in there. So, I think this is for a database session. This is kind of interesting, and I'm actually exercising discipline not to dive into all the other questions. But this is really good stuff. And yes, so your book, right? Do you consider it more of like a, read once or twice, or sort of like a reference book on your journey to optimizing your database?
It could be both, I think, but most realistically, it's probably going to be um, a book where maybe someone picks it up. Maybe they read the first couple of chapters
Mhm.
and kind of get acclimated to the application and the database and whatnot. But then maybe they dive into a topic that's interesting to them based on a problem area that they're having. Like it could be query performance, or we didn't talk about this at all, but kind of maintenance you can perform in the database.
Okay. Oh.
There's a whole chapter on that.
Oh.
Um, so like that's as a reference, man, as of course there's the official first party documentation,
Yeah.
but my goal with the book was really to like, to have real examples that people can look at and practice on, and then they can go and learn to use vacuum and learn to rebuild indexes and things like that locally, so that they're more confident and they have those skills they can take into their production apps. And for that kind of usage, I think it would probably be like, just reading one chapter that's going to help uh, for the problems they're individually facing. But yeah, the book is written in a narrative style. So,
Mhm.
and the chapters are ordered in a way where you could read it front to back. And the chapters are ordered also a little bit kind of reflecting how you might start from a smaller app and then grow into things like replication, sharding, partitioning, because those aren't things that you do on day one. They're things you do when you're, long into your journey.
Mm. Yeah, for sure. I really like that. So I can't wait to read the book because, I feel I've always liked databases for some reason. I just like them. I like the place they sit in our app development stack, and knowing more about Postgres, and even I think it's just also going to help when you use your OLMs, or like even if you're like maintaining or even just a user of the OLM, to let you understand those queries and the decisions you're making. Yeah, thank you so much. Any words you want to say? And of course, coming to the show, you could plug anything. Of course, I know we've been talking about your book, and to me, it's not like a plug because I feel it's going to be really relevant, especially for me because I'm going to read it. And so, yeah, anything you want to say before we wrap up?
Thank you. Yeah, again, thanks for the opportunity to share this with you. I'd say that like part of the reason I chose to kind of specialize more the last few years in databases is because they are so critically important to businesses, right? It's their data. And then it also is this fun combination of deep and complex technology that's very practical and has this performance component as well, which I find really interesting. You know, it's like storing data, but also it needs to be queried and served really quickly, and that's interesting. So I think hopefully what I really hope is that folks that work with Ruby on Rails and Postgres are interested in this book, but I also hope that perhaps folks even outside of Ruby on Rails that might work with like a JavaScript framework or a different language primarily, but use an ORM, like you said, they might get some value out of this as well. It's more of a Postgres book than a Rails book,
Yeah.
and also I think folks can consider like my personal career growth has been through kind of leveling up on some of these infrastructure pieces as a back end engineer, and I do think there's a lot of real world practical value if you're kind of like if you're at all like me, maybe you at some point got a little burned out on JavaScript churn,
Mm.
and you wanted to reach for things that are kind of like reliable and durable. Give databases a consideration. Consider like up leveling your skills on SQL or how query planners work or indexes. All kinds of interesting topics.
Yeah, definitely. I like that. That's really solid because databases have been here for like forever. They're boring. They are very important, and you should know more about them if you're building, applications on the web or any kind of software even that requires data. So, where can folks go to reach you, Andrew? Like, yeah.
Yeah, thank you. Yeah, I'm still pretty active on Twitter/X,
Okay.
and I use the handle and Atki, so ANDATKI. I
Okay.
also blog at andyatkinson.com, which I've been doing for 20 years, like a really long time. um, and I'm also on Mastodon and Blue Sky. Part of the book promotion is just trying to find people and connect with people. So you can find me on most of the social media platforms, or if you want to contact me on LinkedIn,
Mm-hmm.
that's an option as well. And yeah, and I'd love to send some more links your way for folks if they see
Yeah.
this episode and they want to dive into some more things. I'm going to send you some links about like where they can go and do that. Not just the book, but open source stuff too.
Yeah, for sure. So, I will definitely add those links in the description. So, folks, thank you for watching the session. If you have questions for Andrew, leave it in the comment and do not forget to like and subscribe. Yeah. Thank you so much, Andrew.
Thank you.